So verification by simulation. How the verification is done by the simulation. So verify design correctness and verifies ATPG patterns. Okay. So first one. So when we are going to define the simulation, what happens? Firstly, it comes out through the specification. Okay. What is the specification? What type of specifications we are going to define over there? That is going to represent firstly. Nextly, we come out with manual design or via synthesis, and the next one comes out with the test bench development, that is with manual or auto functioning. So in the first one, the specification we have classified with the two things. One is of manual design or via synthesize, and the second one comes out with the test bench development. So that is what once if you develop any logic circuit, it is going to represent it will be defining what is the manual calculations, what is the input and what will be the output that can be defined based on the expectations of the outcome of the circuit. So when we come to the simulation part, what happened? So the expected outcomes and responses and the generated of practical responses will be differed. Okay, so in that cases, what happened? The specifications have been differed in two cases. One is on manual design, and the other is on test bench development. So after developing of each and every module, you'll be defining with the test bench, right? So here also we have one test bench development. In the test bench development, again we come out with the two cases: input stimuli and expected responses. So in the input stimuli, we'll be checking out what was the input pattern. That will be verified in the test bench development. Will be sent to the input stimuli, and from there to the logic simulator. Okay, logic simulator. Logic simulator depends upon the Boolean logic, zeros and ones. So what is the logic that is going to represent here? But in the expected responses, that is to be defined at the response analysis. Why? Because if the expected outcome and the response of the simulated outcome is said to be similar, then there is no problem in the design. That can be faulty free. If there is any fault cited, then you'll be defined with an faulty is said to be noted. That is what the bug is noted, and you'll be get back to the design itself. Okay, you'll come back to the design and set the manual design and come to the circuit description. Is there any synthesize in the circuit verified, and comes to the circuit description, and from there to the logic simulation. So based on the expected response and the response analysis, that is going to be done. If from the logic simulation, it is sent to the simulated responses. Okay, that is what after simulating the responses with respect to the time delay or gate level delay or logical level delay, with respect to all the responses, it is sent to the response analysis from the simulated response. Okay, so totally when we come to the verification of simulator, it depends upon the specifications, which is classified into two sections: manual design and test bench development. From the test bench development, what happened? Again, we have two sections: input stimuli and expected responses. Input stimuli depends upon the logic simulation, where the Boolean logic will be applied. Based on the Boolean logic, you are going to send it for the simulated responses will be identified, and these two are compared from the response analysis. The expected responses and simulated responses are compared at the response analysis. If this is correct, then it is sent to the next design stage. If it is having any bug, if it is having any faulty or failure in the circuit, then it is sent back to the manual design and set for the circuit description, and from there to the logical simulation. So this is what the simulation cycle it is going to represent. So when we come to the concept of test bench, what is an test bench? So test bench comes out with set up a simulation environment, apply input stimuli, run command, observe, response. So the test bench, what is the basic thing in the sense? It collects the set of input patterns sent to the circuit level operation. That is what a behavioral level or gate level or RTL level, circuit simulation, circuit level. In the circuit level, it depends upon the commands. Okay, the logical commands, and from the commands, the circuit level is going to send to the simulated responses. The simulated responses will be compared with the expected responses, and thereafter it is sent to the circuit outcome. Either the circuit is said to be passed or failed.